if you're trying to incorporate a network processing unit, you probably don't want to start from scratch. So James, could you tell us how people can take advantage of MIPS' latest NPU?
Yeah, that's right. So we've got a MIPS S8200 neural processing unit. It's a RISC-V based accelerator. It has not only a RISC-V control core, but it uses the matrix and vector extensions as long with some MIPS custom tuning to be able to support multimodal AI. So you can use the latest LLMs, VLMs, SLMs, all the different LMs to be able to accelerate agentic or physical AI workloads at the edge in an ultra efficient manner. So we're really targeting the lowest possible power, trying to be 4x more efficient than what you've seen from legacy NPU architectures before, while
Mm-hmm.
combining that with the easy to adopt nature of RISC-V. It's an open source standards based core, so it's very easy to use, well supported by all the tooling commercially and open source, and delivers the performance that you need in a very scalable way because it's based around a RISC-V CPU with extensions, so you can cluster it and scale it just like you would a CPU core. So we can scale from, you know, tens of tops to hundreds of tops in a really simple and easy way. So that lets you dial in and build something that can do something like the automotive workloads, something like the bird's eye view transformer, for
Mm-hmm.
example, be able to run that at a acceptable frame rate, 15 to 30 frames per second in under 10 watts. Right, that's a really great target to have because that's something that can fit inside, a lot of different cars, very, very efficient, doesn't drain the battery, but it also gives you all the info you need for parking assist or all the different autonomous modes that rely on multimodal cameras. So, that's more than just the four you see on like parking assist today. That's 8 to 12, maybe even 16, depending on the resolutions, what you're trying to do. So that's the target workload we're
Mm-hmm.
talking about first. That extends into many different applications across industrial markets, as well as aerospace. There's a lot of need for being able to take multi-camera views and integrate them and process them and figure out, what is the environment around me, and then make decisions based on that.
Okay. So how does this scale? It sounds like you can start with a basic RISC-V with its vector support. Can that scale up and then does it move into clusters?
Yeah, that's exactly right. So you start off with the RISC-V control core with vector and matrix extensions, plus local tightly coupled memories and SRAMs that you need for your data processing. And that
Mm-hmm.
instance can then be clustered. So you can make a multi-core cluster of that. Adding again, each cluster can have its own tightly integrated memories, and then you can scale the clusters into multi-cluster instances depending on the target size of the workload. Something we'll be able to let customers do is try this out in our Atlas Explorer virtual platform. So you'll be able to try this pre-silicon in a virtual environment, run your workload, tune your model, understand, how much memory do you need, how much cache size do you need, what do I need to do with my data, how do I prune it, how do I do all of those different things that we see so much, and be able to build all this virtually as a digital twin before you get to silicon, so you can really be confident that you've built the right thing.
What about the software tools? I suspect that most people are not going to want to be programming the RISC-V and the vector system directly.
No, we'll have the compiler and the libraries will be part of the tool chain that we deliver with this. Obviously, there's broad commercial support. So if you have a commercial partner that's doing it, but we also offer that as part of our software services. We'll help you migrate your workload from an existing platform or develop your new workloads for your new instance, depending on where you are. So this is not restricted to only the today's ninja AI programmers that already know how to do this, right? If
Mm-hmm.
you don't have to have that expertise, you can come to MIPS and get that so you can adopt it much more simply and easily.
A lot of these applications are dealing things like audio and video. It sounds like this is much more general in terms of its programming, that you could potentially use some of this for more conventional algorithms that might, prefix or suffix the AI support.
Yeah, absolutely. Because it's based around a general purpose RISC-V core with extensions, then you get all the flexibility and programmability of general purpose processing with the fixed acceleration, but the modality and the flexibility. So, one of the things we see for AI models is they iterate very, very quickly. They're coming out on average every 3 to 4 months. So by using standards-based extensions and general purpose RISC-V base, you get the ability to track those and keep supporting them. The ability to support multiple different models, right? This is not focused and fixed on one model type and say, okay, this is tensor only. You could run all your different frameworks on this device and have support for many, many years.
Great. Well, thanks for filling us in on MIPS NPU support.